Are you familiar with the different type of denial of service attacks that you need to be aware of for the Security Plus exam? If not, well, we're having that conversation starting right now.
You're watching IT Pro TV.
Welcome back to the Security Plus series here at IT Pro TV, and it's looking like a denial of service day for us, and it's going to be a good episode because this is one of my favorite types of attacks, Wes. I didn't know if you knew that, because it seems to be like, oh well, that's low grade stuff, and yet it is super devastating to anybody that's felt the pain of an actual denial of service attack. So I want to get started with looking at what a denial of service attack is and then get down into the different types as well. So let's start off there. What are we saying when we say denial of service?
All right. Well, when we talk about any kind of denial of service, all right, I want you to know that really what it boils down to is an interruption. All right. Now, it's an interruption of more than just one thing, right? Obviously, we could say, it's an interruption of a service. Well, it's in the name, all right? But it could also be an application. It could be a system. It could be facilities. And the reason I say that, these are just some examples. So let's talk about a service, right? You have a DNS service out there, right? Helps us to map IP addresses. A few years back, there was a major distributed denial of service attack, which we're going to talk about in this episode, that took a good portion of the entire DNS system that we use out there on the internet completely offline. It's very devastating, meaning we need that service to be able to connect to web pages. If we look at an application, think of a web application server where you are doing some kind of e-commerce or you're connecting to, and somebody attacks that web server and brings that application completely offline. All right, maybe it's a system. The web server itself brings it offline. Facilities, right? You might say, well, wait a second, Wes, how do we have a denial of service of facilities? We pull the power to your facility. Then you don't have access, right? So these can be any kind of interruption, again, of a service, system, or application. And I put facilities in there because one of the things that I didn't think about early on in my training was the fact that, and I make mention of this, it was Adam Gordon that taught me this, that, again, data centers, think of big data centers. They got these huge exhaust systems. One blanket thrown over the exhaust system and all that heat is self-contained, and now it brings all those systems offline. That's a major type of denial of service attack.
Yeah, I like that idea because we tend to think of everything as just being some digital, really sophisticated attack. You know, somebody's behind a computer screen somewhere doing something, and there's the denial of service. And a lot of times it's exactly what we're talking about. But don't discount the idea that if I can physically damage a system in some way, shape, or form, that's just as good as if I was the most elite hacker out there in whatever country doing crazy stuff, right? So very, very cool. Let's now that we know what a denial of service attack is kind of properly, let's get into the idea of a distributed denial of service attack. Because I was just looking at an article right here. It says that a DDoS, right, the DDoS, can, in general, small businesses lose between $8,000 to $74,000 for every hour of downtime.
Ooh.
Every hour of downtime. So obviously extremely devastating to people's businesses and livelihoods if this is being leveraged against you. Tell us why or how this works so we can see why this is so devastating.
All right, most definitely. So what we're going to do is we're going to set up just a plain denial of service, and then we're going to add to that distributed denial of service component that Dan's talking about. So let's go ahead and just kind of jump in here with the DOS attack here, and then we'll see where does the other D come into that? What does that mean in that acronym? So I'll give you a very basic one that actually is I've seen happen before, and sometimes they're self-inflicted, by the way. You put your domain controller on a cluster and the cluster fails, you can no longer log into your systems. I don't know how that happened.
There's a denial of service attack right there, right?
So this is an authorized user, all right? So nothing's really going on here bad. They're going to make an authentication request, login request to an authentication server. I use that example. It's like a domain controller, right? And then what ends up happening? Well, our attacker sends a whole bunch of bogus login requests against that server. All right, and that server is just so busy trying to answer all of these, and it's probably an automated process too, that the authorized user tries to log in and it cannot provide the service, if you will, to the authorized user, the login service. So that user doesn't have access to, well, pretty much anything in the domain if it's an Active Directory domain. So let's go a little farther here. What do we say? Same situation, user tries to log in, login request, right? We've got our attacker out here. Our attacker sends those bogus login requests to the authentication server. The user tries to log in, and what? Still manages to get logged in? Well, that's because some of the targets have a lot of bandwidth. have a lot of resources. Can you think of a Google web server farm? That's not just a single server. That's thousands of servers.
So it can be pretty difficult for a single individual or a single entity to bring that down because it's a David and Goliath kind of situation.
Absolutely, a good
right?
point. Yeah, absolutely. So now what we have to do is we have to not only meet the bandwidth and the resources of the target, but we have to exceed them. So this is where we bring in, again, same thing, we get our login, but this time we add a lot more to it. We add a lot more attack resources by usually the way of some kind of botnet. We've had some of our users in chat, rightfully so, and I got to bring them into the episode, talk about the old internet relays, right? We have a command and control botnet here, and they simultaneously attack a single target. Now they can exceed the bandwidth and the resources of that authentication server with a whole truckload, tens of thousands, if not hundreds of thousands, of bogus authentication requests. And now when the user goes to log in, no bueno, no food for you. All right, so that essentially becomes what's known as the distributed denial of service attack. It's when the attack target has so much bandwidth or resources that a single attack against it by a single system, even if it's a pretty beefy system, won't bring it offline. So they group hundreds of thousands of computers together out of this botnet and simultaneously attack a single target.
So now we've moved from the analogy of a David versus a Goliath versus now it's looking more like a bunch of ants versus a scorpion, right?
That's
you have
right.
one big,
Yes.
massive insect that could take down any one of those singular ants, but they bring their buddies.
Oh, absolutely.
And they swarm. And as soon as that happens, well, all of a sudden you see the scorpion having a pretty bad day.
A pretty bad day. It ends up becoming lunch.
Yeah, it does do that. All right, so now we know what a difference between a denial of service attack versus a distributed denial of service attack, but there are a few different types of distributed denial of service attacks that we also need to be aware of for the Sec Plus exam, correct?
Most definitely. And the three that I want to kind of bring in here are the three popular ones here. So let's take a look. There are these three right here. There's what's known as the reflected, there's one that's known as the amplified, and one that's known as the coordinated attack. Now, I need you to understand that you could have hybrids of these, all right? You could have where they combine both, a reflected amplified. You'll see what I mean in a second. Let's go ahead, Dan. What do you say we start with a reflected attack?
Let's hit it.
All right, so with the reflected attack, this is going to require a little bit of manipulation of the TCP/IP source address within the packet that the attack is going to be launched with. So we've got our well-groomed attacker here. Our target has this IP address. So the attacker spoofs the source IP address. So even though it's coming from the attacker, the source of the request, the service request in this case, looks like it's the target of the attack, the victim of the attack. And then that is sent to some kind of service request or resource server, like for instance, a time server. All right, time servers, right? We synchronize our clocks by time servers out there on the internet. And those of you that are Linux users know that this is a pretty common thing. You know, with Windows, it typically does this by default on its own. Most of your computers will reach out to time.update.microsoft.com, something like that, or time.microsoft.com, and they'll synchronize that way. All right, now that request is sent to the time server, but the time server doesn't respond back to the attacker like a normal operations. Hey, I need to synchronize time. You send me that time back? No, because it's spoofed and it's the target that looks like the source. And that information is sent over to the target. But remember, that would be like a reflected denial of service attack. And what we're talking about is we need a lot more power behind this attack. So what we do is we bring in, that's right, that botnet again. And that botnet also sends multiple service requests to the time server with the spoofed IP address of the target. And all of those service requests get sent back to the target. That's why they call it reflected, all right? Again, it's using a spoofed source IP address, and that IP address appears as the target who actually asked for the request. Now, the next one is what's known, and it brings it offline to finish the thought process there. The next one is the amplified distributed denial of service attack. And this is one where it does the spoofing as well. But this time, when the service request is made, there's an increased request for the size of the payload, saying, hey, don't just give me a single small few kilobytes, few megabytes back. I'm going to say, I want you to give me hundreds of megabytes back. I want you to increase the size of your reply, and the spoofed IP address is the target. Again, this is distributed, so if we did this just with one, it's not going to take that target offline. So you bet, here comes our botnet, comes into play. And again, they make the same type of request, requesting that the return request come back with an increased payload size that amplifies, right, the server's request back to the target, and then that's what brings it offline. Finally, the coordinated DDoS attack, if you will. Now, this could be more than one attacker with botnets, or it could be more than one attacker on individual computers. The coordinated attack is definitely just a distributed denial of service attack. Instead of a single attacker, we have multiple attackers coordinating their efforts to bring that target offline. For instance, our bogus login request. Not just a single attacker doing a C2 type operation where they're controlling all of those individual computers. You could have more than one, actually each one controlling a botnet. And that's what I mean by this. This is more for abstract purposes, but it's more than one attacker helping to coordinate the distributed denial of service attack.
Kind of giving this a little more tangibility, I think of the famous anonymous group, the hacking group Anonymous, where they did a coordinated attack, a denial of service attack against the Church of Scientology. And that's kind of one of the things that really brought them into the foreground as hacktivists, was that they were able to do that. I've seen things where people that were involved with that were found out by the FBI and got in trouble, and they didn't even realize what they were doing, a lot of them. But they just said, hey, download this software, put this number right here, and hit go, and it starts that denial of service attack. And everybody do that at this time and this date. So it was very coordinated, hence the idea of it being a coordinated attack. Super devastating to the Church of Scientology.
And one of the things that we also mentioned, Dan, and if we, let me kind of back up in my slides here. Remember we said that these could be hybrid attacks? Well, this essentially is a hybrid attack. It tells you the concept of what an amplified attack is. Send me a simple service request, but when I get that response back, I want the payload to be bigger. But notice that the spoofed IP address is the source IP address is the target. So this is a reflected, amplified, distributed denial of service attack. If we put more than one attacker, whoa, here we go, a coordinated, amplified, reflected, distributed denial of service attack. I'm just making that up. These are the three categories that you need to be aware of for the exam, but keep in mind that they can be combined to increase the likelihood of success by bringing the target down.
I go ahead and submit that we create a new category called the trifecta DDoS, where it does all three of those things, and that would be cool, right? That's us. That being said, that's all we have for this episode, but hopefully you found this to be educational and a little entertaining, because that's what we try to do around here, and we are out of time. But we do thank you for watching. We got more in the Security Plus series to come, so we hope to see you then. Until then, have a great day.
Thank you for watching IT Pro TV.